okay? Here are some examples, okay, of basically doing conversion, and we're going to go through examples of conversion, aversion, and contraposition on actual statements, okay? So here we have the statement, all mammals are animals, okay? And when we do conversion on this, we're going to end up with all animals are mammals. Remember, for conversion, all you need to do is simply switch the subject and predicate term. So here in the original statement, you have mammals as the subject term and animals as the predicate term. And when we use conversion on them, we ended up with animals here, okay, and mammals here, okay? What happens then is, in actuality, for that converse, all animals are mammals, what was the predicate term in the A-type statement, original A-type statement, has now become the subject term. And what was the subject term in the original A-type statement has now become the predicate term, okay? Okay? And once again, as we've discussed, these two types of statements are not logically equivalent. So although you can perform the operation on this type of statement to make it into this type of statement, it's converse, okay, you're not going to end up with statements that have the same meaning. So you can't use conversion to translate an A-type statement, okay? Now here we have the E-type statement, no dogs are cats, and once again, dogs is a subject term here, and cats is a predicate term here. So for conversion, you switch those, and we end up with cats here and dogs here, okay? So we end up with no cats are dogs, okay? And these two statements are logically equivalent statements, okay? They have the same meaning. So you can, in fact, use conversion to go back and forth between E-type statements, okay? Now, here is the I-type statement. Some birds are animals that fly, okay? And once again, here is the subject term, and here is the predicate term. And for conversion, we switch these. So here we have animals that fly, okay? And this was the predicate term from the original statement. And birds is over here, which was the subject term from the original statement. And after we've done conversion, as we've spoken, what happens is, what was the predicate term of the original statement now becomes the subject term, and what was the subject term of the original statement now becomes the predicate term. Now, if you're a little bit confused about this, here's what you need to keep in mind. These P's and S's represent terms, okay? And we use them generally to represent the subject and predicate term. However, what actually defines the subject term as the subject term is the position it takes in the categorical statement, okay? And what actually defines the predicate term as the predicate term is the position it takes in the statement. So because the P here now, which originally represented the predicate term, is in this first position, it becomes the subject term, because the subject term is always going to be the term that takes the first position in a standard form categorical statement. And what was the subject term in the original statement now becomes the predicate term in the converse, because what defines the predicate term in a categorical statement is the position it takes in that statement, okay, which is the second position. Now, once again, these are logically equivalent statements, so you can use conversion on an I-type statement in order to translate back and forth, okay? So here we have the O-type statement, okay? And remember, there are only 4 standard form categorical statements, A, E, I, and O, okay? So the statement reads, some fish are not sharks. So fish is the subject term, and sharks is the predicate term of the statement. And in the converse, these have switched. Shark takes the position here now, which is the subject term position, although we're maintaining that variable P to represent that term. And fish is now taking the predicate term position, although still we are maintaining that variable S, okay? So here we see that these two statements are not logically equivalent. They don't have the same meaning, okay? So for these two, this type of statement, you can't use conversion in order to translate one type of O statement into the other type of O statement. Now, here are examples of aversion. Okay, so what you're going to do is Notice here you have all, which is indicates an affirmative, and you switch the quality of that to a negative, so you have no. We didn't change the quantity, so both statements are still universal statements. All we did was change the quality, going from an affirmative to a negative, okay? Then the next step is to change the predicate term with its term complement. So here we have mammals as the predicate term, and we've changed that to its term complement non-mammals, okay? And so you have the statement, no cats are non-mammals, and this is the obverse of the statement, all cats are mammals. These two statements are logically equivalent statements, so they have the same meaning, okay? Here you have the E-type statement. You change the, again, quality without changing the quantity. So if it's a universal, it must still be a universal. But if it's an affirmative, you change it to a negative. In this case, we have a negative, and we're going to change it to an affirmative, okay? And then we change the predicate term with its term complement. So here we have the predicate term lizards, and we change that with its term complement non-lizards. Okay, so you have no sharks are lizards, and the obverse of this is all sharks are non-lizards. Okay, and again, these are logically equivalent statements. Okay, here we have the I-type statement. Some birds are animals that fly. Okay, and we have maintain the quantity. So notice how here the quantifier is simply indicating the quantity, it's a particular, and we've changed the quality though, and for the I and the O-type statement, when you change the quality, what gets changed is the copula, not necessarily the quantifier like the E and the A-type statements. Okay, so here we went from an R to an R not, okay, and this changes the quality without changing the quantity. Okay? And then what we've done is replace the predicate term with its term complement. So here we have the predicate term, which is animals that fly, and we now have the term complement as the predicate, which is non-animals that fly. Okay? So we have some birds are animals that fly, and the obverse of that is some birds are not non-animals that fly. Okay, and it's very important that you change the copula here because that's how you change the quality without changing the quantifier. Okay, because if you change the quantifier, you're actually changing the quantity. Okay, again, these two are also logically equivalent statements. And then finally, we have the O-type statement here. Some fish are not shark. Okay, and again, like we did up here, okay, with the I-type statement, we maintain the quantifier. So the quantifier stays some. Why? Because in this case, the quantifier is indicating the quantity of things, not the quality. But what we do change is the copula, because in this case, the copula is indicating whether or not it's an affirmative or negative statement. So here we go from a negative R not to an affirmative R. Okay, and then the second step of reversion, we replace the predicate term, in this case being sharks, with its term complement, which is non-sharks. Okay, so we have some fish are not sharks, and we go from that to its obverse, some fish are non-sharks. And notice how we remove the not in this case. Okay, so we went from the negative quality to the affirmative quality by changing the copula, okay? Now, once again, in these cases, both of these are logically equivalent statements, okay? So, when you look at aversion and how it actually works on or operates on these various types of statements, there are also just a couple of things that you should keep in mind. Okay. Number one, notice how when you do aversion on any statement, you actually change the type of statement you have. Okay. So here you go from an A to an E-type statement, you go from an E to an A-type statement, you go from an I to an O-type statement, and you go from an O to an I-type statement. Okay. So that's something that you need to keep in mind. With conversion and contraposition, you actually don't change the type of statement you end up with. okay? Another thing to realize is in each case, you have logically equivalent statements, okay? So you can use a version on any type of statement that is an I, A, E, or O, okay? And you will end up with a logically equivalent statement, a statement that has the same meaning, which means that you can use a version to translate any of these types of statements, okay, into its obverse, okay? So if you want, let's say, have something like this initially given to you, no cats are non-mammals, what you can use is a version on this statement in order to give you the A-type statement without the term complement in it, okay? So if you have this statement here, no cats are non-mammals, you would then go the other direction, right? So you would change the negative into a affirmative, so you change the no into an all, and then you replace the predicate term, this time it being non-mammals, with its term complement, which is now mammals, okay? Remember, mammals is the term complement of non-mammals, and non-mammals is the term complement of mammals. So these are related to each other, okay? So then you can go from a statement that's an E-type statement which has a term complement in its predicate term with the word non to an A-type statement which does not have non as its predicate term. Okay, so you basically, by translating it from this type of statement to the A-type statement using a version, you've gotten rid of that non. This is going to become very important because later on when we work on standard form categorical syllogisms, you have to make sure that you only have 3 terms. And sometimes you'll have premises or conclusions that will give you more than 3 terms for that categorical syllogism. So you're going to have to work on translating some of these statements so that you only end up with 3 terms. And we'll talk about this a little bit more later on, okay? Okay, finally let's take a look at examples of contraposition. So here are examples of contraposition. You have all cats are mammals, that's an A-type statement, and we use contraposition on that to end up with all non-mammals are non-cats. Now remember, for contraposition there are 2 moves as well, or 2 steps. The first step is to switch the subject and predicate term. So here was the subject and here is the predicate, and we've switched them because now here you have the predicate term and here you have the subject term, okay? And then we replaced both the subject and predicate terms with their term complements. And we did this by adding non to both terms, okay? So we end up with all non-mammals are non-cats. And these are both logically equivalent statements, so it's okay for you to use contraposition on an A-type statement. And then here we have the E-type statement, no sharks are reptiles. Once again, we've switched the subject and predicate terms. So here's the predicate now, and here's the subject, okay? And then we replace the subject terms and the predicate terms with their term complements by adding non, okay? And we have no sharks are reptiles becomes no non-reptiles are non-sharks. And in this case, we don't have logically equivalent statements, so you cannot use contraposition to translate. You can use it to actually perform the operation on the statement, but you're not going to end up with a logically equivalent statement, so you can't use it to do translations, okay? These 2 statements have different meanings, as we've discussed earlier on. Now here is the I-type statement. Once again, you have the subject term here and the predicate term here, okay? And we went ahead and switched these, so now we have the predicate term here and the subject term here. And then we've added the term complement. So we have non inserted with both these terms to make them into term complements. And we go from some fish are animals with fins to some non-animals with fins are non-fish, okay? Now, this, just like the E-type statement, okay, is not logically equivalent with its contrapose statement, okay? So these 2 statements do not have the same meaning. Because of this, once again, you cannot use contraposition to translate a statement like this into a statement like this, or a statement like this into a statement like this. Finally, we have here the O-type statement. Some birds are not animals that fly, And what we did once again is we changed the position of the subject term and the predicate term. So we have here now animals that fly, and birds is over here. And then we replaced both these terms with their term complements, and we did so by adding non, okay? Notice, and this is very important because a lot of students make this mistake when they're using contraposition on an O-type statement. You do not change the copula, okay? So here we have are not as the copula, and you maintain the are not as the copula here, okay? You also don't change the quantifier, okay? And this is the case with all of these, but for some reason students make a lot of mistakes when they're doing contraposition on an O-type statement. So notice how you have some non-animals that fly are not non-birds, okay? So you did not change the copula, you maintain the not in that copula, but you have to turn the predicate term that is, well, the term that's now in the predicate position, which was the subject term originally, into its term complement by adding non, okay? Once again, you can go back and forth between this statement and the above statement, so you can actually start with a statement that's an O-type statement that has term complements or nons as both its predicate and subject term, and then you can remove those by using contraposition. Okay, so you start with this type of statement and then you'll end up with this type of statement. And when you do so with an O-type statement, you have logical equivalence. Okay, so you'll have statements that have the same meaning. Okay, so it's okay to use contraposition to do translations for an O-type statement. Okay, so this basically ends our lesson 3 part 2, and I will see you guys next time for lesson 4. Have a good one.